What is up, YouTube? Welcome back to another Moralis tutorial video in which you're going to check out how you can monitor ERC20 tokens on any EVM chain being burnt and effectively removed from circulation. Tokens might do this for a number of reasons, for example, becoming a deflationary token or burning these tokens to get access to new tokens. But whatever the case, using Moralis streams, you can track any ERC20 token being transferred to a null address and being burnt. So we're going to do this on the Polygon Mumbai testnet for mintable USDC tokens. If we take a look at the code over here, so when the burn function is called, these assets are sent to the null address on this chain, so no one has the keys to this address, meaning that these tokens can never be accessed again and they're not in the circulation anymore. So let's go ahead and jump in to write the contract. We're connected with our account 1. Let's check how many USDC tokens we have. We're loading tokens. We have 40 USDC tokens. So let's go ahead and burn, for example, 10 of these tokens. USDC has 6 decimals, so 1, 2, 3, 1, 2, 3. This will burn 10 of our USDC tokens. Let's write this. MetaMask asks us, do we want to call the burn function on the smart contract? We do. Let's confirm. And now as those are going through, let's open up Visual Studio Code where I have a Moralis Streams webhook endpoint listening to any burns of these tokens, and immediately we get a 0x42 wallet address just burned 10 USDC tokens as we did. So these 10 USDC tokens can never be accessed again. If we check out Google Chrome, check out our MetaMask account, we should now only have 30 USDC coins left, and in our activity we just burned. Here you see I've tested this out a couple of other times again. But this is the power of Moralis streams. Our simple stream is constantly looking at live blockchain events, and this way we can listen to any token being burnt. You can flip this around for any tokens being minted, but if you're interested in this, stay stuck in and I'll show you how to build it.
Hey, I'm Jay, your Moralis instructor from beautiful Finland. I got into crypto in 2020, and I've been building in the space ever since. In my free time, I enjoy running and at the gym, and in the summer, you'll definitely find me at the golf course. Now, let's get stuck in and learn about Web3.
Rightio, getting started here in Visual Studio Code, I have a very simple Express app which will allow us to send our webhooks from Moralis to this endpoint /webhook. Currently, we're returning a response of 200, but in here, we'll write our logic to get the actual address and the amount of tokens that address has just burned based on the Moralis stream that is sent to this webhook address. And we're just running this on port 3000. So for now, what we can do is just destructure the body of the request that Moralis will send us. So const body will be equal to the request. So this is just the body that is coming with the webhook that Moralis is sending. And now we can start this off. So when we create our first stream, we'll see what the structure of the body is. Now opening up the terminal over here, let's go ahead and run npm I to install all the dependencies. All right, now as our dependencies have installed, let's go ahead and start up the server node index.js. And we are listening to streams, but this is only on our local machine on port 3000. So let's open up a new terminal. I have the terminal app over here. Let's zoom in a little bit so you see what's going on. And I have something called ngrok installed. Go ahead and install ngrok on your system. This will allow you to build a tunnel to your local ports so anyone can access them over the internet. In our case, Moralis can send our streams to our local port 3000. Let's zoom in just a little bit more. ngrok HTTP and the port you have your server running on, so 3000 in our case, and see this. Now we have this tunnel. So as long as we send our webhooks to this address, we're essentially sending them to our local machine on port 3000 so we can view the results over here in our terminal on our local machine. So now let's go ahead and jump into Google Chrome, head over to moralis.io. If you haven't created an account, you can start for free, or then you can just log in with your current account. This will bring you to your Moralis admin dashboard that looks like so, and jump into the streams tab over here on the left. And you can simply create a new stream in the admin interface, create it from the admin panel, click next, done, and we can select the address we want to start listening to. But first of all, let's place the webhook URL in this field over here, like so, and remember to append it with /webhook, as that is the endpoint we are listening to over here on our server /webhook, like so. Then jumping back into Google Chrome, let's go ahead and select an address. For this, we have to know the address we want to listen to. And as we're going to test this out on the Polygon Mumbai testnet, let's jump in to the Polygon Mumbai Explorer. And voila, here we have Polygon Scan Mumbai Explorer open, and we have the mintable USDC ERC20 token page up. So this is the address, and if we check out the contract, we can see that in the right contract functionality, we can burn some of these tokens and we can mint them. So it's a perfect example for us to show how listening to burning of these tokens works. So what we'll do is we'll copy this address. We're interested in this address. Let's go ahead and jump back into our admin dashboard, select this address to listen to. So now we're listening to mintable tokens of USDC. And as we scroll down, we can give it a description, minting USDC, then a tag, for example, USDC, and select the network over here. As we are on the Polygon Mumbai testnet, we'll select this. But if you wanted to do the same for any other EVM chain, you have all these opportunities over here, which is very exciting. So you can build this functionality across chains if you wish. Now, for the address activity, as we're transferring ERC20 tokens to a null address, as burning tokens is essentially transferring of ERC20 tokens to the null address, we're going to check out contract interactions, which includes ERC20 transfers. Then event emittance, as we're looking for transfer events. For the ABI, let's jump back into the Explorer over here. On the contract tab, go to the code section, and as you scroll almost to the bottom, you see the contract ABI, contract application binary interface. You can copy this, jump back into your admin dashboard and paste it over in here, and Moralis automatically finds all the events that this smart contract emits. And we're interested in the transfer event. See, you have the from address, the to address, and the value that was transferred. So we'll check that. And because we're only interested in the transfers that happen to the null address, essentially burning of these USDC tokens, we'll have to provide some filters of the receiver only being the null address. All right, and to create this filter, let's start off by creating an array. And within this array, let's go ahead and create an object. For this object, let's provide a topic 0, which is the topic transfer over here, which we're interested in. Of course, if you looked at many of these events, that's how these advanced options which know which event to filter. Now for the topic 0, we have to provide the details of this transfer, which we can copy straight away from here. Copy that and provide this in parentheses like so. And then for the filter, what our actual filter will be, we again provide an object. You can check the Moralis documentation on what type of filters you can provide, but we're going to provide an equals filter because we want the to address to be the null address. So we provide equals, and then the to address, you can check the names of these addresses. So we have the from, to, and value. So we're looking at the to parameter of the transfer event, and this will have to be the null address, which is 0x00000. Like so. And that is it. That is how simply you can filter all the events that this stream gives us. Because if we didn't provide this, all the transfers between wallets would also be streamed for us. But now, as we're only listening to transfers that happen to the null address, we're going to get all the tokens that are being burnt. And you could do this exact same thing for any other token on any other chain. Or if you wanted to listen to all the new tokens being minted, you just change this to filter to a from filter. So all the tokens that are sent from the null address to new wallets would be new minted tokens. And now we can go ahead and create this stream. And just like that, we have our USDC stream with minting USDC as the description. It's listening to the Polygon Mumbai testnet. And if we open up our terminal here on Visual Studio Code, it seems as if we didn't receive the body, but that's only because we didn't actually console log the body. So if we go ahead and actually change this slightly to console.log our body, like so, save this and restart this. So Control C and then node index.js. Now we're listening to the streams again, but now we should be console logging the body of the webhook that Moralis sends. Let's go ahead and restart this. So go ahead and pause the stream and go ahead and activate it again, like so. And now we should have got an empty stream, jumping back into Visual Studio Code like so, as we did. So we see the structure of the webhook that Moralis sends us. We have this nice structure with the ABI, the transaction logs, and already parsed ERC20 approvals, transfers, and the same thing for NFTs. So what we're going to do is we're going to check out these ERC20 transfers as we're listening to the USDC tokens being transferred to the null address, and loop through the array of all the ERC20 transfers that happen in this block that Moralis is streaming to us, and display the information to the user in this terminal in a neat way. So let's go ahead and scroll down over here and change our webhook endpoint slightly. Let's go ahead and remove the console log. And now, rather than just always returning a status of 2000, let's create a try catch where If it succeeds, we return the response, and otherwise we just console log the error and return a response of 400. Now in here, what we'll do is we'll check if we have a body and ERC20 transfers in that body, like so. So if we have that body sent over to us from Moralis and it has the ERC20 transfers array, we can go ahead and loop through all those ERC20 transfers and display that information to the user over in the terminal. So what we do is we just paste this over here. For every burn from the ERC20 transfers array, we just console log this nice burning emojis, the from address just burnt, and the value with decimals, which Moralis automatically parses for us, and then USDC as we're looking at the USDC address, and some extra burn emojis, which will look very fantastic for us. Let's save this now and open up our terminal. Let's go ahead and restart the server, Control-C, and then node index.js, and we can go ahead and test this out. For this, we'll actually jump back into Polygon Scan Explorer in Google Chrome over here, mintable token. And as we scroll all the way to the top, we already were on the right contract page once. Let's check out which wallet we're connected with. And if they have these USDC tokens, we're on account 2 over here that has 30 USDC tokens. So what we can do is connect to Web3 using MetaMask. Okay. And 0x5DA, which is our account 2, is now connected to Polygon Scan over here, and we can burn our USDC tokens. So let's say we were, for example, want to burn 10 USDC tokens. And remember that USDC has 6 decimal points. So what we have to do is add 6 zeros, 1, 2, 3, 1, 2, 3. And now we should be able to burn from our 30 USDC tokens, 10 USDC tokens. Let's write this. And at the same time, let's actually open this up side by side with our Visual Studio Code. Like so, open up our terminal wide so we see all the new streams coming in. Our MetaMask notification asks us if we want to do this contract interaction. We confirm, open up Visual Studio again. Look at this. We have a new burn of 0x5DA, which our account 2 just burned 10 USDC. And if we check out MetaMask, we just saw that we burned some of our tokens. If we check our assets, we only have 20 USDC, so 10 was just burnt. What we can do is now refresh and do the same with a different account, see if that works. So change our account over here in MetaMask. Go to account 1, for example, like so. Account 1, let's connect to Web3, MetaMask, okay. 0x4D2, which is our account 1. Let's check how many USDC we have on this account. We have 95 USDC. So let's go ahead and burn some of these tokens. Let's say we want to burn 5. So 5, 1, 2, 3, 1, 2, 3. We'll go ahead and write this. Now again, let's go into split screen mode, but a bit better this time. Like so, let's open up that MetaMask pop-up. Let's go ahead and confirm this and open up MetaMask again. The burn is pending, and now as it's gone through, the new burn is lively streamed for our server over here. 0x4D2 has just burnt 5 USDC, and it's actually faster processing than MetaMask itself, which still says it's pending, and now it's actually burnt. And checking our assets, now we have 90 USDC rather than that 95, as we've just sent 95 to the null address, and in essence, burnt these tokens, never to be back in circulation. So that is how you can easily stream any burning tokens on any EVM chain. You could also do this for minting tokens. You could change this to any other networks. Today we did this with Polygon Mumbai testnet, but you could do this on the live Ethereum network, Palm network, Optimism, Binance Smart Chain, Avalanche, whatever you can think of, and for any tokens you could think of. I hope this was useful for you and you find cool ways to use Moralis streams in the future as well. I'll catch you in the next one.